magnitude calculations. We'll start with scientific notation. And remember, scientific notation is just basically a way to get rid of a lot of zeros, okay? In physics, we go, as we talked about with scale for length and time and mass, we deal with things that are really, really big, like the size of the entire universe, and we deal with things that are really, really small, like something that's smaller than an atom. So if you're measuring those things in meters, that's going to be some numbers that are hard to write down if they're all using the same units, okay? So scientific notation helps us because it makes the numbers digestible to the human brain instead of just looking at a bunch of zeros. And is anybody not familiar with scientific notation? Okay, so you are. So we'll go through this fast. Really, you just take all the zeros and you capture them here. So your actual digits are here. When we talk about sig figs, the numbers here, scientific notation makes sig figs really easy. You just count these things, okay? If you use scientific notation correctly, the sig fig should be built in. So you don't have to be like, oh, are there leading zeros or they're trailing zeros? You're like, 1, 2, 3, 4 sig figs. Anyone recognize this number? Mole. Yes, it's a mole. It's Avogadro's number, okay? And then, just if you're going the other direction, you just count the zeros this way. So, I think I actually animated this. So yeah, you can see here's the digits, right? And this represents the scale or the order of magnitude. So 23, if you count all of these, you should get 23, all right? Same thing down here, the digits, right? So this has 3 sig figs. You keep the 3 sig figs here. If you count from the decimal place all the way to where you put the decimal place over here, you should have 23. But since you're going that way, it's negative 23. Okay? All right. So just really quickly, as a class, let's figure out how to write the following numbers in scientific notation. So anyone want to talk about this one? Yes.
Is it going to be 5.78 and 10 to the 6?
5.78 times 10 to the 6. That would be big, right? 10 to the 6. So this is a negative. So 5.78 times 10 to the negative 4th, which means that we're going 1, 2, 3, 4. Okay? That's where we get that. All right. And I want to take the next one. But thank you for trying. It's not wrong to be wrong. Yes?
2.34 times 10 to the 4th.
2.34 times 10 to the 4th. So 2.34, and then we move the decimal place 1, 2, 3, 4. Okay? Nice. How about 97? Can we write? Do we need to write 97 in scientific notation? Probably not, but let's just do it because we can, okay? Anyone want to take 97? All right.
9.7 times 10 to the 1.
Yeah, 9.7 times 10 to the 1, because 10 to the 1 is what?
10.
10. So 9.7 times 10, 97. All right. So that's the easy thing about scientific notation. But there's another useful thing about scientific notation besides the fact that it preserves sig figs really nicely. It's a really good way to make estimates. So remember, we talked about the 4 steps in solving a physics problem, and one of the steps right at the beginning is make an estimate of what you think the answer should be so that when you get your answer, you know if it's wildly wrong, okay? Because sometimes you'll get the right digits, but you'll be off by 1,000, which a lot of students are like, well, I got the number right, and you're like, well, yeah, but if I owed you $10 and I gave you $0.001, are you going to be happy with me, right? Right. So decimal places, orders of magnitude matter a lot. So we're going to try a problem, and in this case, I'd like you guys to take about 5 minutes, and I'll walk around and help you out with this, and try to solve this problem on your own. But I just want you to know, if you write these things in scientific notation, and if you're not familiar, if you're I know some of you are rusty on some of your older algebra, either because you haven't done it in a while, or maybe you didn't care about school when you took algebra, or many, many assorted reasons. That's okay, we can review it, but exponent math, once you remember how to do it, is pretty easy, okay? It's really just adding and subtracting and multiplying. It's just remembering the rules of that. So once you write this in scientific notation, basically you take the numbers and you can do them together, and you should definitely round, okay? And then you take the exponents and you move them together. So, yeah. let's try this. We'll take about 5 minutes, and I'll come around. If you have questions, absolutely ask me. But once you get good at this, you should be able to sort of do these almost in your head, like within less than a minute. Okay? Just a, all right, back to real life. This is a lot of stuff to keep track of, and I'm definitely going to screw it up at some point. I already screwed up half the recording from last time, so I'm double recording it now, so at least one of them should be functional. Okay, let's try this out. So the first thing we want to do is we want to write these numbers in a much simpler form that's easier to digest. So 24,998, not great, but what does that look like?
25.
Yeah, you could write that as 25,000, right? Divided by 0.005. But now we want to put this in scientific notation. Now, strategically, there's a couple things you could do here. You could call this 2.5 times 10 to the fourth, which is fine, but then you're doing 2.5 divided by 5, which is 1/2, but then you have a 1/2. So that's not great. However, you could also write it as 25 times 10 to the third, and now you don't actually have to do any kind of fractions because, as hopefully we know, 25 divided by 5 is one of the simple ones, right? So we end up with 5 times 10 to the negative 3, okay? Then we have to just remember how to do exponent math. So if we're 10 to the something divided by 10 to the something, what do we do with the exponents? We subtract them. And then you just have to remember that this is minus a negative, okay? So 25, so we just do each of these separately. So this one we do as its own problem. So 25 divided by 5 is 5, yay, all right. And then this is going to be times 10 to the, we have to do this math over here. And that's going to be times 10 to the 3 minus negative 3, which should give us 6, okay? So this one's kind of a slam dunk, pretty easy to do, okay? Anybody have any questions on that? Anybody a little rusty on their exponent math? Yeah, that's okay. I think even if you're not admitting it, it's okay to be a little bit rusty. But remember, for exponents, if you're multiplying, like if it's 10 to the 5 times 10 to the 6th, what do we do with the exponents? You add them. So this would be 10 to the 11th. If you're dividing 10 to the 5 divided by 10 to the 6th, right, then you subtract. So this would be 10 to the negative 1. All right? Everybody feel a little bit better about that? Cool. That's all you really need to know. And that once you know that, scientific notation math should be relatively easy. Okay. And remember, we're estimating, so we don't care about sig figs and precision so much when we're estimating, right? When we solve problems, what we really want to know is what order of magnitude, so what range of tens, somewhere between 10 and 100, somewhere between 100 and 1,000, somewhere between, 0 and 1, those sorts of things, okay? All right, so for the next one, let's say we're engineers. What do we think pi is? 3. 3, yeah, 3. Also, E is 3. Everything is 3. It's great. Super nice. No, that's I don't know. You'll get it eventually. It's a good engineering joke. All right, what about this other one? Do we want to call this 3 also?
Yeah.
Yeah, but it's going to be 3 times 10 to what? Oops. Yeah, times 10 to the negative 2 because we have to move this decimal point over here, okay? But this is squared, so that's something we have to talk about in a minute. And then down here, do you think we should round this?
No.
You don't want to round it? Just going rogue. You could just divide 9 by 8.9. Yeah, we could call that 90,000, which would be 9 times 10 to the 4. Right? Okay. So the first thing we want to do is we want to deal with all of our little guys. Okay? But remember, we still have to keep track of this guy. So if we do that, we end up with 3 times 9, right? Because it's 3 squared. So 3 times 9 divided by 9. What do we got?
1.
3. 3. 3 times 9 divided by 9. 3. So that's going to be 3. Okay. Times 10 to the, okay, this is where it gets a little bit tricky. So the first thing we want to do is we want to do this part. So we talked about 10 to the something times 10 to the something. You just add them. What do you do in this case? Yeah, you just multiply them. So we have negative 2 times 2. What's negative 2 times 2?
-4.
That's going to give us negative 4. And then down here we have positive 4, but it's negative 4 minus positive 4. So that should give us negative 8. Okay? So that's what our exponent is. So now, without doing anything with your calculator, right? Because I think a lot of us have become very dependent on our calculators, partly because now you probably carry one with you all the time, since you carry a computer that's better than my first computer in your pocket. That's the crutch that we have. And so the problem with a calculator is it's only as good at understanding math as you are. It's really good at doing what you tell it. It's a stupid robot, okay? If you make a mistake in what you tell it, it's not going to know. It's just going to do what you say. So the whole point of this exercise is you need to sort of know what you're expecting your calculator to tell you, so you know if it's doing the wrong thing because you told it to do the wrong thing, okay? Order of operations on them, real fun. You can use like 5,000 parentheses, that usually helps, but it also helps if you know that your answer is way off right away. Okay? Cool. Now we're going to do another little exercise on estimation. I want you to grab a partner, and you can actually walk around. Estimate how fast you can walk in meters per second, okay? And it doesn't have to be perfect, but you want an answer, just a range, especially an order of magnitude range would be good. You could say like somewhere between 1 to 5 meters per second, right? And obviously people walk different speeds, so we're going to have a range. So pick someone, make an estimate, and then I'm gonna ask people how they came up with their estimate once we have done this for a couple minutes.
So here you'll see students came up with anything from less than 1 meter per second to up to 2 meters per second. There was a big range and lots of different ways to measure, but almost all of them came in at the same range. On an average is about 1 meter per second.
And estimate the gallons of gasoline used each year by all the cars in the United States. Okay, just cars. We're not talking about like big rigs or anything else, just cars. Okay, and this is going to be, I want you to get this like 10 to the something between two tens, like 10 to the 6th to 10 to the 7th, or 10 to the 7th to 10 to the 8th, okay? And you can look up anything you need to look up. So we're going to take about 5 minutes, come up with an answer. We'll do the same thing, and then you can tell me how you got your answer, okay? There's no wrong way to do this, but yeah, that's it. Okay, I'm just gonna go around the room and you just give me your 10 to the what. You can say like 10 to the 9 to 10 to the 12, whatever you got it into, okay? Let's start in the back. You guys.
We got 10 to the 11th.
10 to the 11th, okay. All right. Let me just, let's see, what'd you guys get?
10 to the 9th.
10 to the 9th. I'm gonna move these around, so we'll put them in order. 10 to the 11th, we got 10 to the 9th. Back there.
1.45 times 10 to the 11th.
Okay, so another 10 to the 11th. So we'll put a score under that one. 10 to the what?
10 to the 11th.
10 to the 11th.
Plus or minus hybrids and Teslas and all that.
Plus or minus. A range is fine, like 10 to the 11th to 10 to the 12th would be fine. Or 10 to the 10th to 10 to the 11th. What do you think?
I got 10 to the 11th.
10 to the 11th, okay. You guys?
I got
10
10 to the 9th.
to the 9th? Okay. How about over? 10 to the 11th. You guys?
We got 10 to the 19th. I think we're...
Okay, we'll come back to you. What's that?
10 to the 12th.
10 to the 12th. And you're with him, right? So
Yeah,
same
glasses.
thing.
10 to the 10th.
10 to the 10th. Oh, 10 to the 10th. Okay. And so one extra cool thing about this is mean value theorem means this doesn't work for everything, but if it's something knowable and you poll a large enough group of people, the range of guesses will give you the right average answer, which actually seems to be true because from my estimates, which could be not correct either, we're at about 10 to the 11th. okay? But it's a range anywhere from about 10 to the 9th to 10 to the 12th, depending on what you include, because this question isn't very specific, right? It just says cars in the United States, but it doesn't specify like what type of cars. Are we including, work vehicles? Are we including just home use vehicles? Are we including, specialized types of cars? Are we including the pandemic when people's driving behavior drastically changed? So all of these answers are good, except maybe 10 to the 19th. Sorry, guys. But that's the other reason to check your answer with other people, because you can be really outside of the range, and then you might want to rethink your process. So does anybody want to share what they did to come up with this answer? Google? Yes, but what did you Google? Did you just Google the question, or did you Google particular things that you multiplied to get the answer? Yes.
I think we Google how many weeks does it take to put gas in to put the gasoline in the car.
Okay. So how often people fill up?
Yeah.
Yeah. What'd you Google?
We did how many cars are in the United States, and then what the average miles driven
Okay.
year, and then the average mile per gallon for each vehicle.
Yeah. Okay. Those are good. I think the way that I set this up, it was like assuming everybody drives about on average 10,000 miles per year, then you get 20 miles per gallon, which is probably low now that we have some higher mile, MPG cars, and then about 100 times 10 to the 6 cars, right? So almost 1 billion cars, and then that's it. So I got about 5 times 10 to the 10th, and then after I adjusted it for the much more recent years, it ended up moving up to the 11th. Yes.
We just looked up how much unleaded gas was sold.
Oh, that's a good strategy. Yeah. But you see, all these people did different techniques, and most of us got this number, okay? So that's a good vote for good estimation technique, and also for mean value.